Hi, welcome to the environmental science subject, and now we'll be tackling about the chapter 1 of this subject, which is entitled Environmental Problems, Their Causes, and Sustainability. What are the learning objectives of this chapter? First, we have what are the three principles of sustainability? The second is how are ecological footprints affecting the earth? Third is why do we have environmental problems? And lastly, what is an environmentally sustainable society? And now we proceed to the first section of this chapter. What are the three principles of sustainability? But before we proceed to that section, let us familiarize first some terms that we need to understand. First, environmental science. Environmental science is the study of connections in nature, and it's also an interdisciplinary study of how humans interact with the environment of living and non-living things. So this interdisciplinary study involves a lot of science fields such as biology, chemistry, geology, the social sciences like geography, economics, political science, demography, and the humanities. And also, we need to be familiarized with the term environment. Environment is the term we coined for everything that is around us. It includes all the living and the non-living things with which we interact. As what I've said a while ago, environmental science is an interdisciplinary study that involves a lot of fields. So if you look at this picture, these are the fields that is involved with environmental science. We have philosophy, ethics, biology, ecology, chemistry, physics, geology, geography, anthropology, demography, economics, political science, and lastly, philosophy. And in this table, it shows the major fields of study related to environmental science, including its subfields, with their corresponding definitions. Subfield in the study of environmental science is a study of ecology. Ecology is the study of how organisms or living things interact with their environment and with each other. For example, in a pond, you can find a frog, a fish, water lilies, water spinach, and many more aquatic organisms. So the way that these organisms interact with each other and with also the environment, the pond, is what we call the study of ecology. And for each organism, there is a certain species. A species is an organism with distinctive traits or unique traits. And some species can also reproduce and they can mate and produce fertile offspring. Another major focus in the study of ecology is the study of ecosystem. An ecosystem is a set of organisms, so not just one, but a set of organisms interacting with one another and with their environment of non-living matter and energy within a defined area or volume. So, for example, the pond. A pond has a defined area and volume. There are a set of organisms that can be found in the pond, just like the frogs, the fishes, the aquatic plants. So the way that these organisms interact inside that pond and also with the environment is what we call the ecosystem, the pond ecosystem. So let's move forward to another term that we need to be familiarized with, what we call environmentalism. So what is environmentalism? It is a social movement, a movement of people who are morally and socially awakened with the importance of protecting Earth's life support systems for the benefit of everyone and other forms of life. So environmentalism is more practiced in the politics and ethics arena, so not in the realm of science. So those are the terms that we need to be familiarized with when it comes to environmental science. Subsections in this topic is the three principles of sustainability. Then first, we need to define what sustainability means. Generally, sustainability is defined as the ability of Earth's various natural systems and human cultural systems and economies to survive and adapt to changing environmental conditions indefinitely. But for an individual's perspective, sustainability means meeting our own needs without compromising the ability of future generations to meet their own needs. Meaning, we only consume what is needed, what is enough for us at present, so that we do not compromise the ability of the next generation, the future children, in meeting those needs as well. That is what you call sustainability. Three key sustainability principles that are responsible towards Earth's survivability are the following. First, we have solar energy, and life depends a lot on solar energy. Then we have biodiversity, and biodiversity are the one responsible for providing us natural services. And then we have lastly the chemical cycling or nutrient cycling. So due to the chemical and nutrient cycling, there is little waste in nature because they are being recycled back and forth. Now, these three key principles are interrelated with one another. They are interrelated with one another. Why? It's because um, first and foremost, solar energy plays a key role among these three principles because without solar energy, natural capital and the life it supports would collapse. So without solar energy, this one biodiversity would collapse. And if there's no life present here on Earth, then there won't be any chemical cycling that will undergo. So without this solar energy, these two other principles wouldn't be possible. So our lives and economies depends a lot on energy from the sun and on natural sources and natural services. Read on why solar energy portrays a vital role towards the survivability of Earth when compared to the other two principles of sustainability. I've mentioned a while ago that without solar energy, natural capitals present on Earth will collapse. So life itself won't be possible without solar energy because natural capital is just the total or the summation of the natural resources plus the natural services that these natural resources provide towards the living and the non-living things on earth. Now, what are those natural resources? Natural resources can be living or non-living. So, for the non-living, we have the air, we have water, we have soil, also we have land, and the living are those the biodiversity itself or life. Examples of these are the animal life and plant life that are present or existing here on Earth. Now, There are resources that can be renewed or can be replenished. So these are the renewable energies of the sun, the wind, and water. Now, these resources, these energies, can be further classified as perpetual, which means even if we go extinct, the life, the human life and animal life here on Earth, if we go extinct, these energies are still present. They can still exist for a lifetime. Now, another resources are the non-renewable resources, like the non-renewable minerals like iron, the sand, silicon, and many more. And then we also have non-renewable energy, meaning this type of energy can be exhausted or they can be depleted because they have finite amount or number or volume. So this includes the natural gases, natural ores, oil, coal, crude, and other non-renewable energies. So those are the natural resources. And these natural resources, they provide us with natural services. For say for example, the air. With air, the natural resources that services rather that it provides is air purification, climate control, and UV protection. So that's its natural services. How about water? So the water, they are they can be responsible for the water purification and waste treatment. And then the soil renewal. And for the land, we have here food production. So the land is the foundation from which all our plant life, which is our food source. So they provide for food production and then nutrient cycling. And lastly, we have the biodiversity. If we have diverse plant life and animal life, then population control is possible. And pests can be controlled also. So those are the natural capitals that we have. We have the natural resources and the natural services that these natural resources provide. So I've said a while ago that solar energy portrays a major role for this, right? So without solar energy, um, plant plant life cannot generate or reproduce their food because the solar energy is the one being converted by plants into chemical energy. So in the photosynthesis, if you've heard of the process of photosynthesis, one of the major requirements for plants is solar energy. So solar energy plus water or H2O plus the nutrients from the from that they derive from the soil, and through the process of photosynthesis they can generate food or the sugar plus energy energy. So that's how plants that's how solar energy portrays a major role when it comes to biodiversity. Um, Let me erase this first. Okay. How about um, the natural services like climate regulation and air purification and UV protection? So because of solar energy, climate is regulated. So the solar energy that the Earth receives from the sun varies from each region of the Earth. So in the temperate part, so if he's the okay, let me erase that for a moment. So if this is the Earth, we have here the equator, we have the temperate zone, then we have the South Pole and the North Pole. Okay, that's quite ugly. This is the North Pole. So the solar energy that the Earth receives is different here in the temperate zone, different here in the temperate zone of the south, different here in the equator, and different in the north and the south. So, as we all know, we are in a tropical country and it's located right in the equator. So, we receive most of the solar energy from the sun, and that's why we have only rainy season and sunny season. When compared to the temperate zones, they have four seasons because the amount of solar energy that they receive is less when compared to the equator. So that's how solar energy regulates our climate. So that's why solar energy portrays a big role to supporting life systems here on Earth. All right, understood? So we now proceed to now that we've learned the importance of solar energy as one of the three principles of sustainability, let's proceed to the second one, which is biodiversity. Let me write that one. Biodiversity. What does biodiversity mean? So from the word itself, bio means life, right? And then we have diversity, meaning variety. So variety of life. So the variety of life that is present on Earth, like the animals, the plants, the microorganisms, fungi, and many other organisms, the way they develop their communities and the way they live in their habitat is what we call biodiversity. Now, why is biodiversity an important part of the three principles of sustainability? Because first and foremost, biodiversity is our natural capital. It composes of our natural resources, the plants, the animals, um, the microorganisms, the other non-living factors like the water, the air, the sun, the soil. So those are our natural resources and they provide us with natural services. So these natural services are useful to us humans for us to survive on Earth. Um, Next to biodiversity is nutrient cycling. So nutrient cycling is another, the last principle of sustainability. So in nutrient cycling, organic matter from animals or from plants or from any other organisms, when they die, they become dead organic matter. And when these dead organic matter um, is decomposed by microorganisms or bacteria, they become inorganic matter in soil. And this inorganic matter in soil will be later on utilized once more by plants uh, to do the process of photosynthesis. So this inorganic matter will become once again organic matter in plants, and the plants will then be consumed by animals. So that's the cycle of nutrients. And bear in mind that there are five nutrients that is being recycled in the chemical cycling. So we have first the water, then we have carbon, we have nitrogen, we have sulfur, and then we have phosphorus. So these are the nutrients that is being cycled in the nutrient cycling. Today, we're still living in a sustainable way of life, and that is making an immense or greater impact towards environment. The developed countries like the United States, Canada, Japan, Australia, and other Western European countries have had the highest impact towards the environment in the past and in the present, but that is slightly being balanced out by their highly technologized economies. On the other hand, developing countries like ours, the Philippines, like China, like India, like the sub-Saharan African countries and other South American countries, we are the low-income ones. And that means our technologies and economies are less developed when compared to the developed ones. So we are also contributing a higher impact towards our environment. So how do we solve that unsustainable way of living? One of the concepts that is being promoted widely is the concept of sustainable yield. So sustainable yield simply means uh, the highest rate at which non-renewable and renewable resources can be used indefinitely without reducing its available supply. So that's what sustainable develop yield rather means. Another solution is the reduce, reuse, and recycle. To the second section of this chapter, which is how are our ecological footprints affecting Earth?
An ecological footprint is the area of land and water required to sustainably provide all resources at the rate at which they are being consumed by a given population. So what exactly does that mean? Well, let's first look at a slightly overly simplified example. Imagine we've got this small family of four and they live on corn, maize, tomatoes and fish. They've got an area of land that they own and they grow all of their food on that. They don't take anything from outside of that area. Since we've got four people there, let's say that they require 0.25 square kilometers per person to survive. Now, could we say that their ecological footprint is 0.25 square kilometers per person? Well, no, this is drastically oversimplified because the food that is produced is not the only thing that is required. So what exactly is required by an ecological footprint? Well, first of all, we've got cropland. That's the one we've mentioned. That's the area of land for growing food for humans and animals. Next, what about forest land? For example, for timber products. Now, there are lots of products that are produced by forests, but let's think about timber as an example. Do they have a house that's made of wood? Do they have furniture made of wood? Do they have shelving in their house that's made of wood? Any wood product would need to be taken into account. What about built up land? For example, their house. How much area does that take up? The factories that produce the products that they use, they have a certain stake in that land area. What roads do they use? That part of that makes up their ecological footprint. Next, what about carbon? So the land that's required to sequester, which kind of means absorb the carbon that they release. For example, if they burn fossil fuels, they are releasing carbon dioxide to the atmosphere and it requires plants to take that back in. So what area of land of plants is required to do that? Next would be grazing land, and that's the land for the animals for the products that they use. So animals that they eat as meat, as dairy, eggs that are produced, leather for their shoes, this kind of thing. And then lastly, what about fishing ground? Now, we can't exactly measure that as an area of land because fish are so mobile and spread over a large area, and they use ideas of primary production to calculate this, but essentially fishing ground must be taken into account with an ecological footprint. It's always measured in an area per person, and a common and convenient way to do this is global hectares per person. There are a lot of variations in the ecological footprint. It can vary by country because in different nations there are different amounts of electricity use. There are different eating habits and transport methods, all sorts of different things that influence the average ecological footprint of a person in a country. It can also vary per person. You are not going to have exactly the same ecological footprint as your best friend. For example, vegetarianism has a big influence because then that changes the amount of area required for the animals that you would consume. The use of renewable energy. Do you have solar panels on your house? How do you get to school or to work? If you use a car or do you use a bike, this would influence your ecological footprint. According to the Global Footprint Network, the biocapacity of Earth is 1.73 global hectares per person. Basically, that's how large an ecological footprint every person on Earth can sustainably have. The actual ecological footprint that each person takes is more like 2.84. So this begs the question, are we beyond our carrying capacity? Can we continue on like this? Are we living unsustainably? And yes, these numbers do suggest that we are taking more than the Earth can possibly give. But let's try and provide a slightly balanced argument about that. Let's think what a technocentrist might think about that. Is it possible that as we've got more people on Earth, we are going to come up with more technology and more methods to grow things in smaller areas, which would mean the biocapacity and our ecological footprints would actually change? Exam help, how might you get assessed on this? Nice simple question. Outline the concept of an ecological footprint. Well, first off, give the definition. There's often a mark available for that. In this case, that's quite detailed, and it's possible there might be 2 marks available for giving that full definition. The next thing, the ecological footprint includes the population's waste disposal requirements. That's not expressly stated in the definition, and so there might be an extra point available for that. Another one, it can be measured on a variety of scales. Like we've already said, we could measure an individual person's ecological footprint, or we could mention a nation's ecological footprint. And last, it represents sustainability or a lack of sustainability, depending on the size of an ecological footprint.
So we watched the video of a more detailed explanation of what is ecological footprint. And in there, we've seen that we are using more resources more than what our Earth's biocapacity can replenish. So that has led to the degradation of normally renewable natural resources. What are those renewable natural resources that are being degraded? So, for example, we have aquifer depletion. So the amount of uh, fresh water that we can utilize are being depleted. And we have air pollution. Another one is climate change. We have shrinking forests, decrease in wildlife habitats, species extinction, water pollution, and then declining ocean fisheries. Now, one of the offshoots of the degradation of our natural resources is pollution. What is pollution? So it is any presence within the environment of a chemical or other agent such as a noise or heat at a level that is harmful to the health, survival, or activities of humans or organisms. For example, in a water body, if there is a presence of chemicals or agents or any bacteria, biological bacteria that is harmful to the health, survival, or activities of any organisms or humans, and that's what we call the water pollution. Similar with air, if there are presence of any toxic compounds, chemicals in the air that is harmful to the health, survival, or activities of the humans and other organisms, then that is what we call air pollution. Now, there are 2 sources of pollution. We have point source pollution. What is point source pollution? These are single identifiable sources. And examples of that are the smokestacks of here in the picture, smokestacks of coal burning power plant or industrial plant. And then the second source is the non-point source pollution. So these sources are dispersed and often uh, difficult to identify. Example, pesticides blown from the land into the air and the runoff of fertilizers, pesticides and trash from the land into streams and lakes. So there are a lot of sources there. You cannot just pinpoint exactly where the source is. And here in the picture also the plastics and uh, trash are an example of non-point source pollution. Our natural resources have long been studied by people from the past. One of those is Garrett Hardin. So in 1968, the biologist called the degradation of openly shared resources the tragedy of the commons. Now, what is openly shared resources? Now, there are three types of property or resource rights. First, we have private property. So, a private property, an individual or a company owns the right to land, minerals, or other resources available to that property. For example, a 1 hectare land. Any resources that is inside this 1 hectare land is an owner's private property. The second one is a common property, where the rights to certain resources are held by large groups or individuals. Also, it's owned by large groups or individuals. And then the last one, which is the open access renewable resources or openly shared resources. So this is owned by no one. No one owns an openly accessed renewable resources, and it is available for use by anyone at a little or no charge. For example, the atmosphere, the underground water supplies, the open ocean, and its marine resources are examples of openly shared resources. Now, in the book Tragedy of the Commons, Garrett Garrett Hardin explained it in a simple way. Imagine an open pasture shared by multiple cattle owners. So there's a cattle here, cattle, and cattle. So each owners wanted to maximize their benefit from herding in this 16 hectare land. And the only carrying capacity of this 16 hectare land is 20 cows. 20 cows or cattle. Beyond 20 is its tipping point. Tipping point. So beyond 20 or 20 plus cows. So since all those cattle owners wanted to maximize, wanted to increase their benefits from herding in this area, they wanted to increase that. So they increased that from 20 and into beyond 20. So they've reached the tipping point, and that would lead to overgrazing. So that's what the tragedy of the commons explains. So let me erase this first. Now there are solutions in trying to reduce the degradation of our natural resources. First is reduce use by government regulation, and the second one is to shift to private ownership. A while ago, I've said about the tipping point of the grassland or the pasture land in the tragedy of the commons. And another term for that tipping point is ecological deficit. So ecological deficit means the ecological footprint is larger than the biological capacity to replenish resources and absorb waste and pollution. So meaning our ecological footprint is larger than the biocapacity of the earth to replenish resources and absorb waste and pollution. And the reason for that is because we are living unsustainably, but footprints can also be expressed as number of earths it would take to support consumption. Said in the previous slide, An ecological footprint can be represented as the number or total of Earths needed to support consumption. And in this graph, it shows that we are living beyond the Earth's capacity to support our consumption. We are at more close to 1.3 or 1.4. And in order, if we continue unsustainably living with this consumption, it may reach at 2.5 Earths. So we needed 2.5 Earths just to support our consumption if we continue unsustainable living. But if we live in a sustainable way, then that ecological footprint will be decreased into below 1 Earth. That is if we live sustainably. Our method in determining our environmental impact to Earth is the IPAT model. So this was developed in the 1970s by the scientists Paul Ehrlich and John Holdren. So in the IPAT model, I stands for environmental impact. Then P stands for population size. Then A stands for affluence per person, or the purchasing power or the ability of this person to purchase a certain resource or material. And then T, which stands for technologies, beneficial and harmful effects. So this model formula is I is equal to P times A times T. You can see the formula of the IPAT. And here we compare the IPAT between the less developed countries and the more developed countries. So in a less developed countries, the population is high. So the population is high. And their consumption is low when compared to developed countries. And their technological impact is slower in compared to the developed ones, but their technological benefits is much lesser when compared to the developed ones. So that's how we determine and the difference between the environmental impacts of the less developed countries and the more developed countries. So now we proceed to the third section of this chapter, and that is why do we have environmental problems? Experts have identified four basic causes of environmental problems. And first of that is population growth. We have unprecedented exponential growth in population. Second is a sustainable resource use. And then the third one, we have poverty. And the last one is excluding environmental costs from market prices. So what are those examples of excluding environmental costs from market? For example, we do not put a cost to the air pollution that a car makes, or the gases or the smoke that it releases from its exhaust. We don't put any environmental cost for that. So that's an example of excluding environmental costs from markets. So in this picture, we have population growth, we have unsustainable resource use, and then poverty, and then excluding environmental costs from markets. Why the population growth is one of the four basic causes of environmental problems, it's because the human population are growing exponentially at a rapid rate. So the human population, if it increases at a fixed percentage, then we will be experiencing a doubling of larger and larger populations. So in a projection, the human population in 2009 was about 6.8 billion. But by 2050, the projected population of the Earth will be, human population of the Earth would be 9.6 billion. So in order to fix this growing human population, then we need to slow the population growth. Now, this graph shows what exponential growth means. So as you can see, from 2.5 million years ago up to here, an estimated 1000 AD, when the Black Death occurred, population growth was slow and at a constant rate. But when the Industrial Revolution occurred, that is from, I think, 1800s, we experienced exponential growth. So the growth of the population just went straight up from the current population of 2 billion during the Industrial Revolution. It became 7 billion, and it will continue to increase more by the 2100s. Mentioned a while ago during the IPAT model, one of the factors in the environmental impact is affluence, or the purchasing power of an individual or person to consume resources. Now, affluence has harmful and beneficial environmental effects. The wealth of an individual results in high levels of consumption and waste of resources. For example, an average American consumes 30 times as much as the average consumer in India. Then there we have the shop until you drop affluent consumers who are afflicted with a disorder called affluenza. So they can't stop because of their affluence or their capability of buying stuff like luxury materials, services. They've developed a disorder called affluenza. So affluence has also a beneficial effect. One is it has provided better education, scientific research, and technological solutions that have resulted in improvements in environmental quality. For example, safe drinking water. So that's the negative and the positive effects of affluence. Another basic cause for environmental degradation is poverty, and it has harmful environmental and health effects. Now, poverty occurs when the basic needs for adequate food, water, shelter, health, and education are not met. Which means if you can't eat thrice a day and your shelter is not adequate for human survival and water availability to you is scarce, and then your health is compromised and your education is lacking, then you are in a poverty level. So once 1 in every 5 people live in extreme poverty, meaning they live by just $1.25 per day. So this population are really susceptible to environmental degradation. And poverty has caused tremendous environmental problems and health effects as well. Because this population who are on the poverty line are forced to degrade the environment because of their need for short-term survival. Now, some individuals have different views about environmental problems and their solutions. So some of us don't view an environmental problem in the same lens. So we have our own environmental world worldview. Environmental worldview. So, an environmental worldview is a set of assumptions and values reflecting how you think the world works and what your rules should be. So that is our environmental worldview. This where environmental worldview provides the backbone for our environmental ethics or our beliefs on what is right and what is wrong about the way we treat the environment. So environmental ethics. Now, there are three types of worldviews. And first of that is the planetary management worldview, which holds that we are separate from and in charge of nature. So planetary management worldview says that we are separate and we are in the char- we are in charge of nature. We are the boss of nature. Second one is the stewardship worldview. It holds that we can and should manage the earth for our benefit, but that we have an ethical responsibility to be caring and responsible managers. And then lastly, we have the environmental wisdom worldview, which holds that we are part of and dependent on nature, and that nature exists for all species, not just for us. So those are the three environmental worldviews. Third section. Now we proceed to the fourth section, which is what is an environmentally sustainable society? Environmentally sustainable society, first, we must protect natural capital and live off its income. This includes increased reliance on renewable resources. So we need to increase our reliance more on renewable resources than to non-renewable resources. What are those renewable resources? Solar energy, wind energy, wave energy. So these are resources that are renewable, so they can be replenished. Another is protect our natural capitals. So as what I've said a while ago during the three sustainable principles of survivability by the earth, we need to protect our natural capital because without it, then life wouldn't be possible on earth. Then we can work together also to solve environmental problems. One of those is by trade-off solutions that will provide a balance between the benefits and the costs. And second is individuals matter, especially in the success of bottom-up grassroots action. So we need to undergo um, a lot of bottom-up grassroots action that will aim to provide solutions to any environmental problems. Those solutions provided on the previous slide are just some of the solutions in order to attain a sustainable society. But there are the three main ideas in order to achieve a sustainable society. First, we have rely more on renewable energy from the sun. That's the first big idea. Second is protecting biodiversity by preventing the degradation of the Earth's species, ecosystems, and natural processes, and by restoring areas we have degraded. So protect our natural capital. Third one is help sustain Earth's natural chemical cycles by reducing waste and pollution, not overloading natural systems with chemicals, and don't remove natural chemicals faster than the cycles can replace them. So those